Welcome to lesson 12.5. We are adding and subtracting rational expressions. Now, with rational expressions, just like with fractions, you have to have common denominators in order to add or subtract. So that's the tricky part with all of these. So in our first example here, we're going to subtract 3x plus 5 over 3x squared plus 2x minus 8 from 4x plus 7 over 3x squared plus 2x minus 8. So when we write that problem out and we have the fractions here, we see that we have common denominators. So we're taking the 3x plus 5 from the 4x plus 7. So the first step is to write the problem out. Then, because we've got common denominators, we can subtract our numerators and slide the denominator. So here's what our expression looks like now. Now, with subtraction, as with anything with those signs, you got to watch those signs. So we're going to distribute that negative. We're subtracting everything in from the second fraction from the first. So as I distribute the negative sign, I get a numerator that looks something like this. We have 4x plus 7 minus 3x minus 5. So we can combine like terms. And we are left with 1x plus 2 over 3x squared plus 2x minus 8. Now, I wonder if my denominator might have a common like term that I could reduce that fraction. So I'm going to factor that denominator if possible. And here's what I get. And lo and behold, guess what I have? I have an x plus 2 in my numerator and a factor of x plus 2 in my denominator. So those two factors will cancel out. And we'll zap those out because they reduce to 1. And guess what we're left with? 1 over 3x minus 4. So go ahead and try the next two on your own, and when you're done, you can check your answers. Watch your signs, especially when you're subtracting, and don't forget to factor your denominators and reduce if possible. The beauty of these next two examples, though, the denominators are the same, so you don't really have to think about it. In our next example, we're going to have to come up with our own common denominator and work from there. So here we're adding 3 over 4x plus 1/8. Well, if we look at these, our denominators are not the same. Since our denominators are not the same, we need to find that least common denominator. In this case, it's going to be 8x. So if 8x is your least common denominator, what do you have to multiply the first fraction by in order to get 8x in your denominator? If you guessed 2, that would be correct. So you're going to take the 3 force x, and you're going to multiply it by 2 over 2. And that should leave you with 6x over 8x. The second fraction, you're going to need to multiply by x over x. So when you do that, that leaves you with x over 8x. So now we can add our numerators, and we get 6 plus x, and we slide our denominator, and that's 8x. Because our numerator doesn't have any factors, we are done. So here you can see the answers to the two quick checks. We're left with 14y squared plus 9 over 21y to the fourth. And in B, we are left with 5 times the quantity b plus 1 over 12b squared. Watch that there, because since we can take a factor out of 15, we can reduce that last final answer by 3. Remember, only factor factors. You made a pledge. So here we are adding expressions with polynomial denominators. So notice we've got x plus 4 in our one denominator and x minus 5 in the second. They're not like denominators, so we have to make them like. So our least common denominator is going to be a combination of multiplying x plus 4 times the quantity x minus 5. Yes, that's a cubic trinomial. That's what we worked on the whole last unit. So in our first problem is we are going to, here's our expression. and we want to add them. So our least common denominator is going to be a combination of x plus 4 times x minus 5. So if I multiply my first fraction by the x minus 5 over x minus 5, and my second fraction by x plus 4 over, oops, that should be a plus 4 there in the denominator, we end up getting x 7x plus or minus 35 plus 3x plus 12, and then our denominators, notice how our denominators are like. So now we can add our numerators and slide our denominator. And again, our common denominator is that x plus 4 times the x minus 5. So we're left with something that looks like this. And then we can simplify it, you bet. We're going to simplify that down, combining like terms, to 10x minus 23. Now, if you look at 10x minus 23, you're not going to be able to simplify that anymore. And so you're done. Unless there was a 10x minus 23 in our denominator, which there isn't. I personally don't care if you multiply this or you leave it in factored form. I find it's easier to leave the denominator in factored form because chances are if you're going to be able to factor the numerator, you're going to see those factors pretty easily. Go ahead and try the quick checks on your own, and I'll be back with you after. Hoping you gave those quick checks a good shot. Now remember, these don't come naturally. These aren't easy problems. So you've got to take your time. You've got to show your steps. Do not try to do a lot in your head or you will find problems later on. So just please, please, please be careful. Write your work, show your work, and we can help you out and find your mistakes if you are making any. So in quick check A, we've got 8t plus 7 over t plus 4 times the quantity t minus 1. And again, leave those in their parentheses. Do not worry about foiling that. It's fine. In the second one, we've got 3a squared plus 2a plus 2 over a plus 2 times 2a minus 1. And again, there was no way to factor that numerator. It's what we, I guess, call prime. And so therefore, we're kind of done with that problem. So here we are looking at an air travel problem. If you read the problem, you're told that you can go faster from Miami to Seattle, about 14% faster than you could with the reverse. So if you look at our problem, we know that the trip is 5,415 miles, and we're going to let R be our rate. So that's our rate from Miami to Seattle. So then from Seattle to Miami, our rate is going to be 14% faster. So notice how we have the 1.14 here. That is showing that it's 114% of the original rate. So here is our fraction. And here is our fraction representing Seattle to Miami. We're going to add those, but in order to add them, we have to have like denominators again. So we're going to multiply our first fraction by 1.14 over 1.14. And we're left with 6,173.1 over 1.14 r plus 5,415 over 1.4 r. We can add our numerators and slide our denominator, and now we have a simplified expression that represents our total time, okay, because time plus time, that's going to represent our total time there. And you can just leave that simplified expression as it is. Eventually, once we start solving these, we will set this simplified expression equal to a value, possibly a time in hours, and from that we can figure out our rates. But I'll leave that for another day. Go ahead and try one on your own. Here we're traveling from Atlanta to Albuquerque, New Mexico, and the trip is 1,270 miles. So notice we've got distance over rate equals time, again, just like in our previous problem, and our distance is not going to change. But our rates are a little faster going from Atlanta to Albuquerque than the reverse. So we set up our fractions, and then we find a common denominator, and then we add our numerators and slide our denominator for a value of 2,692.4 over 1.12r. That's it for adding and subtracting rational expressions. Please be sure to finish those post-video checks for me, and I'll see you in class.